Yeah, so I'm currently a mechanical engineer, spacecraft mechanical engineer at NASA's Jet Propulsion Laboratory in Pasadena, California. I worked as an intern there first in 2014 and 2015 while I was going to school at University at Buffalo, getting my undergrad degrees in mechanical and aerospace engineering. And then once I graduated in 2016 from UB, I took a full-time job with JPL and moved out to California and have been working there ever since. I was hired on to work the way our workflows happen. Usually people are assigned to different missions or projects. And so I was brought on to work on the InSight Mars lander, which was originally supposed to launch in 2016, but then got delayed for 2 years to 2018. So I tell everybody that mission getting delayed was the best thing that ever happened to me because they wanted cheap labor to come and kind of take care of stuff. So that they hired me on. I had interned for that mission. Um, and so as a mechanical engineer, I could talk for a while about the wide range of stuff that I do for these projects. A lot of really interesting and exciting stuff. But to put it, concisely, I do a lot of integration and testing, and then a lot of assembly, test, launch, and operations. So within a lot of space missions, you have a spacecraft that will be in a design phase, really early, just sort of blue sky, whiteboard, what do we want it to look like? And then after it gets designed and fabricated, there's often a different team, at least within NASA, and I've only ever worked within NASA, where we'll then have people who come in and actually build the spacecraft, put it together, take it through all the range of testing that goes into making sure it'll work in space. So again, could talk for a long time, but to be brief, that'll be thermal testing, dynamics testing, EMI, EMC, electrical testing, functional testing. In the case of these things that land on other planets or asteroids, we just need to, if we have a robotic arm, we have to make sure that the robotic arm works. Or in the case of the Mars rover, we drive it around the Mars yard to make sure that it's going to work as we expect. And so I worked on the InSight lander for 2 years, but then starting in late 2017 and really up until 2020, I was working on the Mars 2020 Perseverance rover, Curiosity was the previous rover. It's funny, I know it's got the name Perseverance now, but I'm so used to calling it just M2020 because that's kind of and so within that same deal, I was doing a lot of integration and testing, built a test bed inside of a large 10-foot thermal chamber to test out the subsystem that drills rocks on Mars and puts them into tubes that are then being left on Mars to be returned back to Earth with another mission that we're currently working on. And then also worked with a lot of the flight hardware, again, focusing primarily on the sample caching subsystem, as we called it, which is really the big robotic arm, if you see in the news at all, that's doing any of the drilling, things like that. Just making sure that that works. And so I did that. And then in the past year, I've moved on to another mission. It's the Psyche mission, which is going to be going to an asteroid in 2023 between Mars and Jupiter.
Oh my God, so cool.
Yeah, really exciting. Sometimes it's funny, the rover gets a lot of news attention, as it should, because it's so cool and really a feat of engineering, but there's a ton of other smaller missions that kind of keep the lights on that are still really cool, but aren't quite as flashy or expensive. One of my favorite parts about my job is on any given day, I drive on to lab and I have almost no clue what might come at me. We of course schedule things out and plan well in advance, but with the type of work that I'm in, once you're putting this stuff together and testing it, you're always running into issues. And so you have to solve those often before the end of the day. So really quick turnaround. So I love the variety. I love that I never really know what's going to be coming at me. To give you a more detailed answer, nominally, like right now, and when I was working on the Mars rover, I'm really rarely behind my desk. I have a cubicle, but I almost never go there. I'm very often on the floor. We call them the high bay or the clean rooms. These are the sort of large hangar-like spaces you'll see where, I put on a full bunny suit, mask, gloves, boots, frock. We have all of our cleanliness requirements. And so go into this space where the actual spacecraft is. We call it the flight hardware. It's going to go to Mars or to wherever that might be. And it often it's just, what's the problem of the day? We have to get this part integrated, but it turns out that it doesn't quite fit right. So now we have to go machine it down to get it to the appropriate level. Or, okay, today we're testing this arm, transferring over this tube to a different robotic arm on the rover. And during that test, we're running the test, and then something doesn't quite fit right. So then we have to assess the data. And so, again, I'm trying to give you a direct answer to your question. I think it pulls in a lot of physics, a lot of mechanics, a lot of machining technology, a lot of just how do you build this thing that will go into space. But there's also a fair amount of computer programming. That's not necessarily my expertise. We do have teams that specialize in safe flight software that put that together. But oftentimes those people will be in a different test bed or a different literal physical space where they're computers writing the code that then they can send to the rover. And so they might hand that over to us and say, okay, run this. I didn't necessarily design it or program it myself, but then I will run it and have to be able to understand all the data that we receive back. Is there a strange load that we're seeing, or is current really high, or is the temperature increasing too much? Just anything you can think of when it comes to making sure that this all works. When I was working on the rover, that was a really big, really complex spacecraft that was managed entirely by JPL, which is one of a number of NASA centers like Houston and Kennedy Johnson Space Center. And so a lot of that we really had ownership and responsibility for. And so we had a lot of people that we were putting towards it. And so for that, right, on my sort of subsystem integration and testing team, that was maybe 7 of us. But then that integration and testing team was part of the larger sample caching team that was maybe anywhere from 150 to 175 people that are mechanical specifically. And then you expand that out and you look at all the other just mechanical teams working on the rover, you're looking at probably close to 250 people. And then you consider that's just the mechanical. There's electrical, flight avionics and software, technicians and machinists that are doing a lot of this work on the hardware, and then working with international organizations that deliver small piece parts that might be some particular science instrument that's, more or less a widget that we attach on. And so as you expand it out, how many people worked on the rover at the end of the day? That could be 1,000, 2,000. The lab that I'm at, we have about 6,500 people on average that are working at that location, but that's across a wide range of missions and projects. The last thing I'll say is, by comparison, this project I'm working on now, Psyche is the name of the asteroid. It's also the name of the mission. On that team, our mechanical team for the entire mission is about 5 people. And that's because it's a smaller mission, because we've done a lot of contracting work with other organizations. And so when NASA structures these missions, they kind of try to do so in a way where they can contract out a lot of the work to other organizations, international space agencies, or just companies within America. Psyche is an asteroid, a lot of asteroids in our solar system and certainly in the galaxy and the universe, but they're often rocky that we see in our solar system. And this particular asteroid, via science methods that honestly are a bit above my head, they've determined that it's made primarily of metal. And I believe it's like a nickel alloy, but it's a metal asteroid, giant metal asteroid, which is unique. what they think, planetary scientists think, is that this may be a ancient planetary core or a piece of a core that may have, rather than forming into a full planet like we see Earth or Mars or any others being, for whatever reason, shrunk over time and turned into this solidified metal asteroid. It's about 140 miles across, so still quite large. And
140 miles is the size of it, is the size of the asteroid.
Diameter of the asteroid. And so what the mission of Psyche is this probe to go, and we have a number of science instruments, imagers, magnetometers, spectroscopers, again, things that are a bit above my head in terms of my expertise, but they are going to go and look at this asteroid and try to determine, is this an ancient planetary core? And if so, what is it actually made of? What does that tell us about what we know about other planetary cores and about the formation of planets, not only in our own solar system, but really across the universe? And so it's really interesting, working for in space in general, but certainly for NASA, where often we have missions that are looking at the Earth and Earth science, but then we have missions that are going to the moon and to Mars to really set up a presence there. But then we also have solar system exploration missions that are looking how the solar system formed. Mm-hmm. And then of course we have telescopes that are looking out into just the furthest depths of the universe. And all of that stuff fits together to, not only create a narrative about how the universe formed and what have you, but also about what we can expect to have happen on Earth and just better understanding our own processes, both at the millions of years level and even just in the past century, some of the changes that we see. I was studying engineering at UB, and I will admit I didn't necessarily know what that would look like. I was always fascinated and inspired by space, and so when I had the opportunity to intern at NASA, I was just applying to any engineering company that would take me. But then when I landed the internship at NASA, I really fell in love with their mission and goals. And so now that I've been there for, coming up on 5 years, I've gotten some awesome experience. I've gotten, to touch every part of the rover that's now on Mars doing its thing. I can see things on Mars in the images and point to that, say I had a hand, one of many, in putting it all together. But I for myself have had to kind of take a step back after these years and say, what's sort of the next thing? And I'm still trying to answer that question. I will say we're entering a phase in space exploration that I think is really, really groundbreaking, where we got to the moon in the 60s, but then we stepped back from the moon, and then we had the International Space Station. We were working, with a lot of international organizations to have that going. And now, currently, the presidential administration is saying that we'll be back on the moon by 2024, and we're working to do that. I think a huge thing that's changed in the past decade is now we have private companies that have a huge hand in a lot of this. So SpaceX, Blue Origin, Boeing, and those are just kind of the big names. The list goes on and on and on about companies that are developing rockets, spacecraft, satellites, landers, rovers, not only to go and do all these things that traditionally only NASA did, but bringing people to the surface of Mars, like SpaceX, and the moon first, like SpaceX is doing. And so to be a part of this industry right now, it's just constantly changing in a way that's so exciting. We're also seeing private citizens start to go into space as tourists. Of course, they're paying, I think upwards of hundreds of thousands, if not millions of dollars for a ticket. So not super accessible yet. But I don't think it's crazy to say that in the next several decades, we could start sending, the average person into space to live and work, which as crazy as that sounds and as far-fetched and sci-fi, if you look at a lot of the work that's happening today in these companies, that is the goal. And there are dozens, if not hundreds of billions of dollars being spent to make that happen. You can point to SpaceX missions and Virgin, I forget if it's Virgin Galactic or Virgin Orbit missions, where you have, traditionally your astronaut was somebody who's in the military or had 3 PhDs. And I don't know that that'll necessarily be me at this point in my life, but we're starting to see space become so much more accessible to individuals, businessmen, private investors, things like that. And the technology is only improving. So do I expect that I'll be on the moon? I'll definitely keep my fingers crossed. And for the rover specifically, because of COVID, we couldn't get
Oh,
together at that time.
yeah.
And that was honestly a huge bummer, because what would have happened is we all would have flown to Florida to see the rocket launch together. And
Oh,
then when the rover landed on Mars 6 months later, we would have been, all on lab together in some shared space
uh-huh,
to watch that. Um, there is, you can look up online, there's video of the people that are in the mission control.
uh-huh,
They are more operations engineers, which, again, not to get too long-winded or technical, there are a number of my friends who are in that room, but they specialize in actually driving the rover on the day of, which I certainly could do, and would think would be very fun in the future. But for my current role, by the time the spacecraft was on the rocket, I was already moved on to the next thing,
uh-huh,
because that's kind of how our cycles work. But certainly for me personally, I've been in situations like that in the past for the InSight lander and for other missions that I had a smaller contribution on. And to see the rocket launch, to see the thing land wherever it's going to go or just do what it has to do, is pretty just incredible. And definitely it's a little scary, because I don't know, I can't think of another industry off the top of my head where you think, yeah, I worked on this for 3 years, other people worked on it for 10 years, and now this is the moment. It's either going to land and we're all going to be super busy tomorrow, or it's not going to land and we're all going to have to update our resumes and figure out what we're going to do from here. And, that's being a bit funny, but it is quite that dramatic sometimes. And so
uh-huh,
to see it land and start working is a huge relief. And for me personally, a huge source of pride when you get those photos back from Mars and you
uh-huh,
see there's that bolt I turned, there's that hardware I designed, there's that change I made. And it's kind of like maybe when you direct and make a movie, you can see all the scratches and whatnot that stand out to you that don't really matter, but lots of stories about this nick or dent there.
uh-huh,
Um, and so that was a really special experience. Unfortunately for the rover, we couldn't all be together, but we did
uh-huh.
still do a live stream and a Zoom to be together, and we're watching in real time. And NASA actually put a ton of time and effort into creating this basically website you could go to where you would get flight data
Uh-huh.
that was going to mission control, but then they were also casting it out to all the employees. So you could literally see what mission control was seeing and participate in that way. Which again, I think just goes back to my point earlier about how space is really becoming more accessible to everybody. And it's definitely an exciting time to be a part of it. There's a single narrative that leads to where it was a bit of a circuitous path, but I'll just tell you and you can pull from there. When I was at St. Joe's, I did a ton. I was on the soccer team, I was in the musicals, I was in the plays, I was in the jazz band, I was in the swing choir. And I don't say all of that to try to boast, far from it. It was just St. Joe's allowed me to just explore everything I was interested in. And I really, by the end of my St. Joe's career, I kind of was scratching my head like, geez, what do I want to do? Because I had all of these fantastic experiences. You mentioned Mr. Heller. I took all, honors chem and AP chem with him, which was great. I'd taken some physics courses. I was in AP calculus and really enjoying that. So in my head, I honestly didn't know what I wanted to do. But I was loving my time at St. Joe's. And so when I was looking at colleges, I applied to and auditioned at a couple music schools, like Eastman over in Rochester. I applied to some engineering schools. And ironically, I applied to UB as my safe school, not really expecting that I would go there. But, I got a great scholarship to UB.
Uh-huh.
And I, not really knowing what I wanted to do at that point, I thought, well, geez, I'll go to UB and save some money and kind of figure out what classes I want to be taking before I go to,
Yeah.
the top school where I don't, really know if I want to focus on that particular thing. And so when I got to UB, I think I was majoring in like economics, environmental engineering, and theater. And so I was just all over the board.
Yeah.
Um, but that said, once I got to UB, I focused in on, again, just sort of in the way that anybody who loves Star Wars or Star Trek or just looking up at the stars at night was inspired by space. I found that really exciting and interesting. And then I took some of those aerospace classes and not only did well in them, but really enjoyed them. And so sort of started off on that path. Even there, along the way, I wasn't sure I wanted to do engineering. I still played a lot of music and considered dropping out more than once, but stuck with it. And my junior year of engineering, just realized, geez, I've never actually worked for a company. And so applied to a ton of internships, and got rejected or didn't hear back from, dozens. But then lo and behold, got an offer for Jet Propulsion Laboratory out in California. And as I've already said, once I got out
Yeah.
there, just fell in love with it and
Uh-huh.
have been able to do some really exciting stuff. So, to bring it back to your original question, if there's anything I can say about St. Joe's, it's that it constantly challenged me, gave me the opportunity to explore anything I really could think of that I wanted to do. And ironically, I felt very prepared technically, mathematically, with the science backgrounds. Like you said, shout out to Mr. Heller.
Mhm.
Honestly, if there's anything that I could take away, it's the theater and the performing experiences that I had at St. Joe's really taught me how to just sort of be a presence in the room, take challenges head on, get outside of my comfort zone. And frankly, in my day-to-day job now, I have to be very comfortable having no clue what's going on or how to do it, because
Uh-huh.
oftentimes we're doing this stuff for the first time. And in a way, as I've reflected on this, I often find myself going back to some of those skills of being able to get in front of 20 people and speak about something that you only learned about 2 hours before. I have such happy memories in all of the things that I did at St. Joe's. I think I have many friends who, one friend in particular just got his PhD in chemistry, and you can draw that line straight back to Mr. Heller's class.
Yeah.
And I loved Mr. Heller's class. I loved a lot of my classes at St. Joe's, but for me, it was just a little bit broader and, like I said, more circuitous. But definitely shout out to Pascal Frazina. Being in all those musicals and plays was such a thrill. And if we're talking specifically about engineering and technical work, I think St. Joe's has started doing robotics and has
Mhm.
maybe first robotics. Get involved in that. Just to learn anything, anywhere you can. That's also, it might be helping your family build a shed in the
Mhm.
backyard, learning how to use those tools and how to kind of calculate and see loads, just exposing yourself to that early on. The sooner you start that, watch a YouTube video about programming. I'm not a great programmer, but that's becoming a huge part of engineering, regardless of the discipline.
Mhm.
And anything you can do just to start learning will have a huge impact. And then from there, as you consider colleges and internships, which I realize is a bit further off, but just don't be afraid to knock on the door or ask the question or send the email, even if you don't feel like you're quite ready yet. If you put
Mhm.
yourself out there and show that you're excited and interested, people will always respond to that. And somebody who's, you know, didn't get straight A's but wants to show up every day and learn, I'd rather have that person than somebody who aced all their tests and doesn't know how to pick up a hammer. So
Mhm.
that would be the technical advice. And then just broader for people who are in high school at St. Joe's, um, take the time to experience it all. Um, just if you want to play a sport, try out for the team. If you want to be in the musical, prepare a song. If you have a teacher you like, stay after class and see what they have to say about everything. Just I had such a great experience at St. Joe's, and I was lucky where I got to take full advantage of it, and I encourage others to do so as well.